going to talk about geometric series. So when you think about geometric series, think about this. There is an exponent. So when there is an exponent in the series, the base matters. All right. So for geometric series, again, the series, it doesn't have to start at 1. It can start at 0. So we have 1 for when 1 for n starts at 1, 1 for n starts at 0. So when n starts at 1 to infinity, we have a times r raised to n minus 1 power. So we start at a when n is equals to 1, 1 minus 1 is equals to 0. So the first term is a because the r is raised to the 0 power. So r raised to the 0 power is equals to 1. And then when n is equals to 1, when n is equals to 2, 2 minus 2 is 1. So that's why the second term, you have r to the first power. When n is equals to 3, 3 minus 1 is equals to 2. That's why you see r raised to the second power. So since this is an infinite series, we keep on going. What if n starts at 0? When n starts at 0, the only difference is in the power, we do not do n minus 1 anymore, because when n is equals to 0, if you do 1, then subtract 1, then you have a 0 minus 1, then that gives you a negative exponent. Not good. All right. So when n starts at 0, you have to remove the minus 1 from the exponent. So the geometric series is still true. So when n is equals to 0, r to the 0 power is equals to 1. That's why the very first term, there is an a in there, because r raised to the first power is 1. And then when n is equals to 1, first is 0, right? And then when n is equals to 1, you have r to the first power. When n is equals to 2, you have r raised to the second power, so on and so forth. So this series converges when the common ratio, the base, the r, the absolute value of r is less than 1. Then the series is convergent. So how do you find the sum? The sum, you take the first term divided by 1 minus the common ratio. So when the absolute value of the common ratio is greater than 1, then the entire series is divergent. So let's take a look at the divergence. So when absolute value of r is greater than 1, so that means the r must be greater than 1, right? So the absolute value of r is greater than 1. So how about 2? When r is equals to 2, 2 is greater than 1. So you are using 2 raised to a very huge power. How come the exponent is infinity? So look at the geometric series. Where is the n? The n is in the exponent. Exponent can go up to where? Exponent can go up to infinity. So think about 2 infinity, 3 to the infinity, 5 to the infinity. They are all very, very large value, right? What is this very large value means? You get an infinity. What is this infinity mean? Listen, this is equals to infinity. Look at the geometric series. What are you doing? You are adding up a list of numbers, right? So at the infinity, so that means when n gets really, really big, you are adding up what kind of values? You are adding up 2 raised to a very large power. That is, when n gets big, you are adding up a huge value to the partial sum. What happened when you add a huge value to a partial sum? Let's say the partial sum is 10. You add an infinity to it. So the sum just becomes infinity. So in that case, the series is divergent, right? So what about the convergent? The convergent is, think about this. Absolute value of common ratio equals to 1. So let's say the common ratio is 0.5. 0.5 is less than 1, right? So if you take 0.5 raised to the 0 power, that is very close to 0. If you take 0.05 or 0.1 raised to the first power, as long as you have a numbers like that, that is always approaches to 0, right? And then, so to give you a better sense of how the number works, so take a look at my notes. 0.5 times 0.5 is 0.025. 0.05 times 0.05 is equals to 0.0025. And then 0.005 times itself, you get more 0. Think about this. If you keep on moving 0.05 times itself many, many times, that means you have a 0 point followed by a bunch of 0 and then a 25. So that kind of number is very close to 0. As you keep multiplying the decimal by itself many times. Now, overall, what does that mean? Hey, I'm still thinking about this. Hey, look at the geometric series. Come on. You are adding up infinitely many numbers. Okay, I passed my elementary algebra. I passed my fundamental math. If you're adding up infinitely many numbers, the sum must be big. Are you kidding me? How can that be convergent? Take a look at the conversion one more time. So when n gets big, what happened in here? When n, not when n is big. When n is big, what happened? You have a base like 0.5 raised to a very large power, right? As a result, the term is very close to zero. I know you are adding up infinitely many numbers. Listen to me. Yes, you are adding up infinitely many numbers. As you move on your list, you are only adding up some numbers that are so close to zero. You have a sum. Let's say the sum is 10, partial sum. You are adding a number that is so close to zero to a 10. What happened? Well, the sum stays somewhere around 10, right? So you have 10. You add something that is so close to zero to it. What happened? You still stay at 10, right? The only difference is you only grow up a little bit at a time. So that's why even though you are adding up infinitely many numbers, so what? The last couple numbers, they are all zero. So you are just adding up a bunch of zero. So the sum must be convergent. The sum equals to a real number, right? To make it even easier, the sum only is determined by the first couple terms. The overall sum of the series is only determined by the first couple terms, because as n goes big, you are adding up a bunch of zeros, right? I only need to know the first two terms. When n is big, so what? They are just zero. That's why the series is convergent. So that's how you interpret the series. Think about the last couple numbers. Are they big? If they are big, then the entire sum is big. If they are small, something close to zero, so what? The sum is just determined by the first couple numbers. So the series is of course convergent, right? Okay, let's do a few exercise. So we have six series. They are geometric. I want you to tell me, are they convergent? Are they divergent? Of course, you do have to show your work. You can't just say it, right? So the first one. So number one, we have 3 minus 4 plus 16 divided by 3 minus 64 divided by 9. There is a technique. You have to keep the first term. So the first term is a 3, right? How do you deal with the second term? To deal with the second term, you have to start with a plus. Since the first term is a 3, that must be a 3 in here. So what you are thinking in your brain is 3 times what kind of power is equals to 4. The answer is 3 times 4 over 3. What about the negative? You put a negative in there to take care of that for me. And then the next number, you have to tell me this. 3 times negative 4 over 3 raised to what kind of number is equals to 16 over 3? The answer is 2. I already told you this is a geometric series, so that there must be an exponent. So the negative 4 over 3 is raised to the first power, and then the next one must start as a 3, and then the common ratio is 4 over 3, so this is the third power, and then you keep on moving, right? So this is my common ratio. R is equals to negative 4 over 3, and then the absolute value of negative 4 over 3, that is greater than 1, so that means the series is divergent. What does that mean? Can you explain this in your own word? As you keep on moving right here, you are adding up very large value to your partial sum. So let's say you have a sum on your hand. Let's say the sum equals to 20. The next value, I want you to add an infinity to it. What's the overall sum going to be? Infinity, right? Because as you look at the right hand side of the summation, you are adding up big values because the absolute value of the common ratio is greater than 1. You add big values to the partial sum, you just make the sum so big, as the result, the sum is divergent. That's how the story works. So even though you are doing plus or minus, I know you are trying to argue with me. Hey, no. We have plus, we have minus, we have plus, we have a minus, right? Because second power and negative, then you get a plus. All right, so that means the sum is increasing, decreasing, just like how the graph of sine works. So the sum looks like this. increasing, decreasing, increasing, decreasing, increasing, decreasing. You will never be able to determine what that equals to, even though you are adding up infinitely many numbers. So that's the first problem. And then the next problem, number 2, you might have to take a screenshot right now because as we move down, you won't see that anymore. 10 minus 2 plus 0.4 minus 0.08 and then plus dot 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 dot. The first term is 10, right? Okay. And then the next term, this must be a plus. You must start at 10. Tell me, 10 times what number equals to negative 2? The answer is 10 times negative 2 divided by 10. Do not simplify the fraction. And then this must be raised to the first power. And then also 10. 10 times what power? What number raised to the second power is equals to 0.4. This you might be thinking in this way. Okay, 10 times negative 2 over 10 raised to 2, is that still equal to 4? If yes, you are on the right track. If no, then you have to figure out another common ratio. And then you add 10 times negative 2 over 10 raised to the third. That must be equals to negative 0.08. Otherwise, your common ratio is wrong. And then you keep on moving, right? So this one, the common ratio is negative 2 divided by 10. The absolute value of R is 2 divided by 10. That is less than 1. So that means the series is not, convergent. 1, that means the series is convergent. And then how do you find the sum? The sum is equals to the first term divided by 1 minus common ratio, which is 10 divided by 1 minus, the common ratio is negative 2 over 10, right? So negative 2 over 10, so that is 10 divided by 12 over 10. So that is 10 times 10 divided by 12, so that is equals to 25 divided by 3. So that means even though you are adding up infinitely many terms, listen to me right now, even though you are adding up infinitely many terms, the sum is going to be equal to 25 divided by 3. Because as you move up, so you have negative 2 over 10, and then you raise that to a very large power, that is going to give you something very close to 0. Yes, even though you are adding up many numbers, the last couple numbers or those a bunch of numbers, they are just all zeros, right? So the sum is really determined by the first couple terms. When you get to the last few terms, they are all 0. I don't care. So that's why this is convergence. All right, so moving on to the next one, number 3. So number 3, we have a sum, n goes from 1 to infinity. You have 12 times 0.73 raised to n minus 1. So this is a geometric series. And then the ratio is equals to 0.73. The absolute value of this is less than 1. So that means the series is convergent, right? And then what is the sum equal to? The sum is equal to the first term divided by 1 minus r. So what's the first term? The first term is you plug in a 1 to it. So 12 times 0.73 and then 1 minus 1 and then divided by 1 minus 0.73. You clean up the math. That is approximately equal to 44.44. So even though you are adding up infinitely many numbers, as you move on, you have 0.73 raised to a very large power, so they are just very close to 0. So you are just adding up a bunch of zeros as n gets really big. So the sum is determined by the first couple terms, because in the first couple terms, you will see math like this: first power 0.73 to the second power. So the sum is really determined by the first couple terms. Okay, so far so good. Then we move on to number 4 then. So in number 4, we have the sum. N goes from 1 to infinity. We have negative 3 raised to n minus 1 divided by 4 raised to the n. So this one we have to work the number out a little bit. So so this is how we are going to do it. So that is the sum. N goes from 1 to infinity. Negative 3 to n minus 1. The 4, we have to write like that, 4 to the n times, this is an extra term, 4 to the first divided by 4 to the first. Why do we have to do this? You will see why in a minute. So that is the sum, n goes from 1 to infinity. The top, no change. And then the bottom is 4 to the n times 4 to the first, and then divided by that. So if you consider these two terms together, so 4 to the n divided by 4 to the first, that is 4 to the n minus 1 times 4 to the first. Why do we have to do this? Do you still remember this? X raised to the n power divided by y raised to the n power is equals to x divided by y raised to the n power. Since the negative 3 and the positive 4, they share the same exponent, so we can just divide them. So back to the green, that we have infinity, n goes from 1 to sum, n goes from 1 to infinity. So the one, these are 4, it doesn't affect it. There is no n attached to it, so we can just factor it out. And then we have negative 3 over 4, and then raised to the n minus 1. If you hate writing out, putting a number out there, it is okay to put it right over here. That doesn't affect anything. So what is the common ratio? The common ratio is r is equals to negative 3 over 4. The absolute value of that is what? The absolute value of that is 3 over 4. That is less than 1. So this is a geometric series. Common ratio is less than 1, so the series is convergent. Converges to what? So the sum is equals to the first term divided by 1 minus r. The first term is you plug in a 1 to it, because the series starts at 1. So 1 over 4 times negative 3 over 4 raised to 1 minus 1 divided by 1 minus negative 3 over 4. So if you clean up the math, the top is 1 over 4, the bottom is 7 over 4. So you have 1 over 7. That is the sum of the series. So even though you are adding up infinitely many numbers, so as n gets big, the negative 3 over 4 raised to infinity is something close to 0. So for big N, you are just adding up a bunch of 0 that doesn't really change the sum at all. So the sum is really determined by the first couple terms. Maybe N goes from 1 to 10. They determine the sum. As N gets really, really big, those values, they are so small, you add that to the sum, that doesn't change the sum. And then we have number 5. So let's use another color for number 5. Number 5, we have the sum. N goes from 1 to infinity. We have e to the 2n divided by 1 raised to n minus 1. I picked this problem because I want you to practice the exponent. So that is 2 to the square, the whole thing raised to the n. And then the bottom is 6n, and then 6 negative 1, right? N minus 1. And then do you see that the e to the second and the sixth, they are both raised to the n? So that means here is what we can do. We can do that, n from 1 to n, we can do this. Look, we can do e squared divided by 6, they both raised to the n, right? And then this 6 to the negative 1 is a 1/6 in the fraction. So 1 divided by 1 over 6 is just equals to 6. Okay, so what is the common ratio? The common ratio is e squared divided by 6, right? So that divided by 6, is that greater than 1? So this is approximately equals to 1.23. So the absolute value of 1.23 is greater than 1. So the series is divergent. Alright, so that would be the end of this video. If you think my instruction is helpful, let me know in the comment section below. Subscribe, like the video, share the video for me. Appreciate your help as always. In the next video, I have more to say about the basic concept of series. So I will see you all in there. So that is signing out for now.